Hi everyone, so now we are going to learn about what is photon. So photon is actually a quantum of electron wave energy which denote as h times f. So it means that when we say one photon energy means it's actually Planck constant times the frequency of the electromagnetic wave. So h is equal to 6.63 times 10 to the power of negative 34 joule second, and f is the frequency of the wave. So every type of wave have different photon energy depending on the frequency where the wave processes. So we have the higher frequency, that means we have higher photon energy. So this table shows that a few photon energy for the electromagnetic wave. So you can look through and understand it, the relations between the photon energy and the frequency. Okay, next is, so what is mass of photon? So a mass of photon is not actually rest mass because the photon will not at rest, it will always moving. Okay, so the mass is actually equivalent to the photon energy. So how do you get your mass for a photon? So from the Einstein mass energy equations, which is equal to mc squared, and the photon energy, which is equal to hf, these two equations will help you to get the mass for the photon. So mc squared will be equal to hf, so equal these two equations, then you will get your m is equal to hf per c squared. So this one is the expressions for your mass of photon. Okay, then how do you get the momentum of photon? So from here, mass of photon, you know that P is the momentum for a photon is actually mass times velocity. So the mass for a photon is in sfc squared. So the velocity for a photon is the speed of light or speed of the electromagnetic wave, which is c. So p, the momentum will be equal to hf per c. So this is your expressions for the momentum of a photon. Okay, so now let's say the incident ray or incident light is incident on a metal surface, and this photon of energy is being absorbed or it hits the metal surface. So when the photon hits the metal surface or hit some surface, it will exert an energy. So there are two possibilities of force exerted by photons. One is when the photon is absorbed by the surface, where the change in momentum, because let's say this is your photon, is being straight shine on or incident on a surface, so this photon will be absorbed, means that the change is initial that it has p equal to h per lambda. So we know that momentum is equal to h per lambda. So final, because it's being observed, so the momentum of the final product will be equal to 0. So the change in momentum will be equal to h lambda for the magnitude. Okay, so this is the change in momentum. Let's say not only one photon, there are a lot of photons. So if n is the number of photons incident on the surface per second, of course light wave incidents on the surface, it will produce a lot of photons. Okay, so in 1 second there will be a lot of photons. So the rate of change of photon, so we know that the rate of change of photon is equal to dp dt. So now n is the number of photon incident on the surface per second. So n has the unit of per second. So in other words, to find your rate of change of momentum will be equal to n times p, where n is equal to in terms of per second, P will be h per lambda. So this is your rate of change of momentum. Okay. Then what is the force exerted on the surface by a photon when it's absorbed by the surface? So we know that F is equal to dp dt. So it will be equal to nh per lambda. So this is the force exerted by the photons when the photon is absorbed by the surface. Okay, this one is for absorbed by the surface. What if the photon doesn't absorb by the surface? Instead of absorbed, it is reflected. Okay, when it's reflected, sorry, there's a spelling mistake, so it's reflected by the surface. So let's say now photons being hit on the surface and then reflected. So it means that here you have a change in h lambda, and here also momentum equal to h lambda, but both are in opposite direction. So remember, momentum have directions. So in other words, a change in momentum will be equal to 2 times h over lambda. So it's 2h over lambda for the change in momentum for reflected surface. So now it's not only one photon incident on the surface. It's have several photons. So you have a lot of photons in 1 second. So the rate of change of momentum now will become np, where n is in per second. So p will be 2h per lambda. So in other words, you have 2nh per lambda for the rate of change of momentum. Then because F is actually the rate of change of momentum, so the force exerted on a surface by photon for reflected photons will be equal to 2nh per lambda. So this one is for reflected photons. Okay, so next, what is power of light source in terms of photon energy? So we know that light source will emit a lot of photons in a second. So P is equal to E per T. Power is equal to rate of change of energy. So now let N as the number of photons per second. So it means that these expressions will become N times E, because N is the number of photons per second which carry the unit as S per S negative 1. So NEP will be equal to, this is power, the capital P. So P is equal to NE. So since E is equal to HF, so NHF, where this one is the power for the light wave, okay, or for the electromagnetic wave. So now you are all clear about photons. So photons has mass, and photon also has momentum, and it will causes force exerted on a surface. So how do you calculate it? By using these equations. So see you in my next lesson. Thank you.